let's try a more realistic way of subnetting a network to make the most efficient use of all the bits. This is what we call variable subnet mask or VLSM. Remember, when you perform classful or what I sometimes call as the classical subnetting, all networks have the same number of hosts because they all use the same subnet mask. So this leads to inefficiencies. For example, if you borrow 4 bits on a class C network, you need to end up with 14 valid subnets and 14 valid hosts. A serial link to another router only needs 2 hosts, but with classical subnetting, you end up wasting 12 of those hosts. Even with the ability to use NAT or private addresses, where you would never run out of addresses in a network design, you still want to ensure that the Iep plan to be created is as efficient as possible. So this is where the VLSM or the variable scale subnet mask comes into play. Basically, VLSM is the process of subnetting a network or subnetting a subnet rather, and using different subnet masks for different networks in your Iep plan. What you have to remember is that you need to make sure that there is no overlap in any of these addresses. Our main objective in this example is to create an Iep plan. So the Iep plan consists of the following columns. Namely, we have the departments, the network, the CIDR, the subnet mask, the range of the valid hosts for each network, and the broadcast address. So under the department, we have 4 departments all in all, and connecting each of these departments are the links. Okay, so the first thing we need to do is to sort the number of hosts needed for each of the departments. Basically, HR office needs 50 computers or 50 hosts. Finance office needs 27 hosts. The MIS office needs 12, as well as for the research office. And each of these links or each of the link connecting these offices needs 2 IP addresses. So we identified 2 for each of these links. All right. Next, after sorting the departments from the largest number of computers down to the lowest, the next thing is to identify the number of host bits for the first department. So using now the formula 2 raised to h minus 2 should be greater or equal to 50. Again, 2 raised to h minus 2 should be greater or equal to 50, where h is the number of host bits to satisfy this number. Okay, minus 2 because we exclude the network address and the broadcast address. Alright? So, what is the value then of h for us to satisfy these requirements, which is 50? Now, we do some trial and error again. What is h? Alright? So, let's try h is equal to 5. It's greater or equal to 50. So, if h is 5, basically that's more or less 31 or 32 minus 2. So, this will not satisfy our requirements, which is 50. Okay. What if rather our h is equal to 6? Okay, so 2 raised to 6 is more or less 64 minus 2, that is equivalent to 62, more or less 62. That is greater or equal to 50. Okay, so at this point, 6 as the value of h is true because it is greater or equal to 50. You can assign h to be 7, but we need the number which is closest to our requirement. In this case, closest to 50. Therefore, our h here is equal to 6. Now, we define the number of host bits for finance department, which needs 27 hosts all in all. So, what will be our network number for this department? Okay? So, to determine how many number of host bits to assign for this department, okay, again, we need this formula, 2 raised to h minus 2 should be greater or equal to 27. The nearest number greater than 27. So, in this case, h will be 5 because 2 raised to 5 is 32 minus 2, that is 30. So 30 is the closest number which is greater than 27. Okay? Therefore, our h is equal to 5. Okay, h is equal to 5. Okay. So, going back here, previously we created 4 networks or 4 subnets. But the second subnet, which is the .64, was already assigned to our HR department. So, you choose from the remaining network number, what will be our network number that will be assigned to our finance office. Okay. So, in this example, we use the .28. Okay, we use the .28. Remember, .28 was this one, 10000000, where 2 bits are for the network and 6 bits for the host. But we only need 5 hosts this time. 5 hosts this time. So, we do not change the first 2 bits because it is already intact, which is the .28. Let's just concentrate on the third bits here, or third bit. So we only have one n, rather. Okay, we only have one n here. Okay, from our formula, 2 raised to n, where n is the number of bits. How many possible combinations can we produce? So, 2 raised to 1, that is equal to 2. Okay, we can produce 2 possible combinations of n here. Okay, so we have 0 and 1. Okay, we have 0 and 1. Okay, we simply copy the first 2 bits. We have 1, 0. And then, for the remaining 5 bits, okay, assign it to 0. Okay, so this will now be equal to 128 and 128 plus 64, 32. 128 plus 32. 0, 60, 160. Okay, so we have 2 subnets created from that 1 to 8. Okay, 2 subnets created. Remember, the CIDR notation for these addresses are all that slash 26. Slash 26. Now, from 192.168.100.128, which is slash 26. After subnetting, we created these two additional subnets. So we rewrite. So we have 192.168.100.128, 192.168.100.160. Okay, so we have two additional subnetted networks. Okay, so we have V128 and V160. Okay, so what will be the CIDR notation for these two new subnets? Okay, two new subnets. So in here, we have 3 bits already for the networks. 1, 2, 3 on the port octet, because we only need 5 hosts to satisfy the required number of hosts in the finance department. So we have 1, 2, 3, 4, 5. Okay, assign 1 to all networks, assign 0 to all hosts. So converting this into decimal, so we have we have 2 to 4. Okay, we have 2 to 4, and it's CIDR notation. So we have how many number of network bits? Okay, 16, 24, 25, 26, 27. So we have slash 27. Okay, for these two new subnets, the CIDR notation now will be slash 27. Okay, slash 27. Okay, this slash 26 for that 128 will not be used or cannot be used already. It can't be used because this is already a subnetted network. Subnetted. Okay, so we can use only this one, 1, 2, 3, 4. But since our requirement is to only have 5 hosts, we only choose from these two. Okay, 1 to 8 and that 160. Okay, so for this example, we choose that 128 slash 27 for our finance office. Okay, finance. Okay, so back in our Iep Plan, finance office, we have 192.168.100.128 slash 27. Okay, slash 27. And the subnet mask value 255, 255, 255, 224. Okay, 224. Now, what is the range of valid hosts? Range of valid hosts. So, based from here, we we have 1, 0, okay, 1, 2, 3, 4, 5. Okay, originally, 1, 0 was our came from 1 to 8. Okay, and the additional 0 for the networks is from this one, 1 to 8/27. Okay, so what will be the first valid host? Okay, simply this is 1 to 8. Okay, our network number. The first valid number is 1 to 8 plus 1, that is equivalent to 1 to 9. Okay, so our first valid host here is 192.168.100.129. Okay, and converting this one into all ones, 1, 2, 3, 4, 5. Okay. Okay, this is equivalent to 159. Okay, so we converted all host bits into all ones. Therefore, this is our broadcast address. Okay, so our broadcast address here, we have 192. 168, 100, 159. Okay? Okay, our last valid host therefore is not turning all host bits to all 0. We retain the last significant bit into 0. So therefore this is equivalent to 158. Okay? 192, 168, 100, that 158. Next, we need to define the next department, which is the MIS. So this department needed 12 computers or 12 hosts. Okay, so we need to define subnet, okay, for this department. So from the list of table, we have 1, 2, 3 subnets, okay, which can be used to define 12 number of hosts. Okay, so how many number of host bits are we going to define, okay, to satisfy this number, which is 12? Okay, from the formula, 2 raised to h minus 2 should be greater or equal to 12. Okay, what will be h in order for us to produce the greatest or greater number than 12, which is nearest to 12? Okay, so in this case, we need 4 to be the value of h, because 2 raised to 4 is 16 minus 2, that is 14. So 14 is the nearest number greater than 12. Therefore, our h here is equal to 4. Okay, we only need 4 host bits to satisfy 12 number of hosts. Okay, so here we need to convert this one into network, remaining the 4 host bits. Okay, so for the network bits, we need to turn it into 1. Okay, so therefore, converting this into its decimal equivalent, this is 240. Or the CID rotation, 8 plus 8 plus 8, 24 plus 4, this is 28/28. Alright? So, since we only need 4 host bits, choose among the remaining available networks. That's 0, that 192, that 160. Okay, since we only need less number of hosts, we can use this one. Okay, that 160. So we need to subnet this one, that 160, which is 101.0.0.0.0. Okay, remember, we only need 4 host bits. Therefore, this will now become network bits or network bit. Okay, so from the formula 2 raised to n to define the number of combination. 2 raised to 1 because we only have 1 bit for the network that is equivalent to 2. So we can produce 2 possible combinations of zeros and ones. So what are this? We have 0 and 1. Okay, and then just copy this one, 1 0 1, 1 0 1, and then 0 0 0 0, 0 0 0 0. So this is equivalent to 160. And this is equivalent to 176 because 160 plus 1, 2, 4, 8, 16 is 176. Okay? So these two subnetworks are already our /28. Okay? So we produce now additional 2 subnetworks, which is 192.168.100.160 and 192.168.100.176. Okay, these 2 are already our /28. Okay, for that 160/27. This cannot be used anymore because it is already subnetted. Okay, the same with 128/26. Okay, can be used. So we can only use that 160 and that 176 for our MIS and research department. Okay, so concentrate on our MIS first. Okay, 160. So we can assign now this to our MIS department. Okay, so this is for MIS. Our network 192.168.100.160, which is /28, and the subnet mask value 255, 255, 255, 240. Okay, 240. So what is our first valid host here? We have 101, we have 0, 0, 0, 0. This is our first valid host. Okay, 160 plus 1 is 161. Okay, we have 192, 168, that 100, that 161. Okay, if this host bits are turned into all ones, this is our broadcast address. So this is equivalent now to 192.168.100.175, I guess. And to determine the last value host, okay, do not turn all host bits to all ones. So this is 174. Okay, that is for our MIS department. Alright. Next, how about for the research department? Again, they are the same. 12 number of hosts. Okay, So the same, 2 raised to h, that is 4, 14, h will be equal to 4. Obviously, they have the same requirements, which is 12. Okay, therefore, we have 1, 2, 3 available networks. Okay, so which of these networks are we going to use to assign it into our research department? So basically, we can use the 176 because 176, okay, 176 only needs 4 host bits as well. Okay, the same with the MIS department. So you can directly assign now the network 176 to your research department. Okay, so for our research, we have 192.168.100.176/28. Subnet bus value 255.255.255 that the same 240, and then first valid host. Okay, so we have 101 10000. Okay, 101. Okay, so this is for the host bits. So this is equivalent to 176, assigning 1 to the last significant bit, that is 177. Okay, our first valid host therefore is 192.168.100.177. Okay, if we convert all host bits to all 1, this is our broadcast address. So 1011 plus this one, okay, this is equivalent to 191. That is our broadcast address. Okay, so 192.168.100.191. Okay, and to define the last valid host, retain 1 bit, which is turned to 0. So this is equivalent to 190. 192.168.100.190. So that is for the research department. Okay. Now let's try to define also the number of valid hosts for link A, link B, link C, and link D. Remember, each of these links have the same number of hosts, which are 2. Okay, so basing from the formula, 2 raised to 8, h minus 2 should be greater or equal to 2. So what is our h? Our h is 2. So 2 raised to 2 is 4 minus 2, that is equivalent to 2. Okay, so our h here should be equal to 2. Now, where are we, what network number are we going to assign for us to define these links? Okay, remember, we have only 2 remaining network numbers here, the .0 and .192. So you choose. Okay, you choose. So for this example, we choose .0. Okay, we choose .0 here. Okay, so our h here is 2, therefore we need to convert this one into network number. Okay, the remaining two hosts are for 2 bits rather are for hosts. Okay, so converting it into its decimal equivalent, this is equivalent now to I2. Okay, or CIDR rotation 24, 25, 26, 27, 28, 29, 30 slash 30. Okay, slash 30. Alright, so we use the dot zero. We use the dot zero. Okay, originally we have 0, 0 and okay, and the remaining are for the host bits 1, 2, 3, 4, 5, 6. Okay, so we only need 2 host bits. We only need 2 host bits. Therefore, convert this into NAT rate. 1, 2, 3, 4. Okay. The remaining are 4 hosts. Okay, the remaining are 4 hosts. So we have 4 n's here. Okay, from the formula 2 raised to n to define all possible combinations of zeros and ones, 2 raised to 4 is 16. Okay, we can produce 16 possible combinations of zeros and ones. What are they? We have 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. Next, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 all in all. Okay, and then just attach 2 zeros here. And then for the host, assign 2 zeros as well. And then convert this into its decimal equivalent. So this is 0, 4, 8, 12, 16, 20, 24, 28, raise 32, 36, 40, 44, 48, 52, 56, and 60. Okay, so these are the numbers being produced from here. Okay, 100.0, which is all /30 numbers. Okay, so we rewrite. And 192, 168, 100.0, 192, 168, 100.4, 192, 168, 100.8, 192, 168, 100.12. Okay? Since we only needed 4 links, link A to D, let's just concentrate on these 4 numbers. Okay? 4 subnets. The remaining, which is 16 until 60, these are reserved, or these are for future expansion purposes. Okay, but for the sake of defining the requirements from our example, we only needed 4 subnets. Okay, so this is all /30. Okay, we have 2.0 here, since this was already subnetted, okay, which produces 16 numbers. Okay, this can't be used anymore. Can't be used because they are subnetted. Okay. So for link A, we can assign this one for link A. This is for link B, link C, and link D. Okay, link D. So what are the numbers? Okay, department. Okay, link A, we have 192.168.0/30. Okay, and then subnet bus, that 252, 255, 255, 255, 252. Okay, range of valid hosts. Okay, range of valid hosts. Concentrate here. Okay, we have only 2 hosts. Okay, we only have 2 hosts. So if these 2 hosts are all zeros, this is our network number. Okay, so we assign the first bit or first host, okay, to be 1. That becomes now 0, 0, 0, 0, 0, 0, 0, 1. That is equivalent to 1. Okay, so this is 192.168.100.1. If we turn all host bits into 1, this is our broadcast number. So 1 plus 2, that is 3. 192.168.100.3. Okay, our last valid host, therefore, okay, we retain 10 from the host bits. This is equivalent to 2. So until 192.168.100.2. Okay, that is for link A. How about for link B? Link B is, we have that 4. We have 192.168.100.4, which is also /30 number. Okay, subnet mask 255, 255, 255.252. Okay, that's 4. This is that 4. Okay, so first valid host 4 plus 1, that is 5. 192.168.100.5. Last valid host, we retain 10 here. So this is 4 plus 2, that is 6. 192.168.100.6. And for broadcast number, we set all host bits into 1. So 4 plus 2 plus 1, that is 7. 192.168.100.7. Alright? For link C, we have that 8. 192.168.100.8, which is also /30. And subnet mask is the same. First valid host, that 8 is 10. So we have 8 plus 1, which is 9. 192, 168, 100, that 9. Okay, last valid host, 8 plus 2, that is 10. 192, 168, 100, that 10. Okay? And for broadcast address, 8 plus 2 plus 1, that is 11. So we have 192, 168, 100, that 11. Okay? Lastly, we have link D. Link D. So we have that 12. 192, 168, 100, that 12 slash 30, 255, 255, 255, 252. Okay? First valid host, so that 12 is 11. So we have 8 plus 4, 12. First valid host plus 1, that is 13. 192, 168, 100, that 13. Last valid host, that is 14. 8 plus 4 plus 2, that is 14. So if 192, 168, 100, that 14. Okay? And then lastly we have 12 plus 2 plus 1, that is that 15. 192, 168, 100, that 15. So this is now our Iep Plan table. Okay? So all of the requirements for each department was plotted here. Okay, what are the networks? What will be the subnet mask to be used? And what are the valid hosts, range of valid hosts to be used? Okay? So to check, to counter check, HR needs 50. That is from 65 to 126. So nearly equivalent to 50. Okay? Nearly equivalent to 50. So there is only minimal number of costs being wasted. Okay? So from the finance office, from the range 129 to 158, more or less, the range is 30. So we need 27. For the MIS and research, I think that is from 161 to 174, that is 14. Okay, 14 range. Each range is 14. So use 12 from 14. Only 2 IP was wasted. And for all the links, this is exact. So therefore, no IP was wasted because it is being used. Okay. Now, look at this one. For that 192, this will be used for future expansion purposes, as well as this one. Okay. If there are future links later on, this can be used. So that is the computation for the VLSM. That is how to conduct VLSM for Class C networks. Thank you.